f of x equals 2x and g of x equals x squared uniformly continuous on R. To determine if the function f of x equals 2x is uniformly continuous on the real number line R, we need to verify the definition of uniform continuity. So this says that a function f is uniformly continuous on an interval if for every epsilon greater than 0, there exists a delta greater than 0, such that for all x and y in the interval, if the absolute value of x minus y is less than delta, then the absolute value of f of x minus f of y is less than epsilon. So let's start with the function f of x equals 2x. We need to find a delta that satisfies a condition for any given epsilon greater than 0. First, we calculate the absolute value of f of x minus f of y. That's going to equal the absolute value of 2x minus 2y. And from there, we can factor out a 2 to get 2 times absolute value of x minus y. Now, we want this expression to be less than epsilon. So we have 2 times the absolute value of x minus y is less than epsilon. To isolate the absolute value of x minus y, we divide both sides by 2 to get absolute value of x minus y is less than epsilon over 2. This tells us that if we choose delta equal epsilon over 2, or the greatest integer greater than epsilon over 2, then for any xy such that the absolute value of x minus y is less than delta, we will have that the absolute value of f of x minus f of y is less than epsilon. Therefore, the function f of x equals 2x is uniformly continuous on R. Now we're going to do the same thing, but we're going to look at x squared. So this is the definition. And we're going to start by expressing, this time, f of x minus f of y. Technically should read g of x minus g of y. But that's just the absolute value of x squared minus y squared, which we can factor this into absolute value of x minus y times the absolute value of x plus y. We want to find out if we can choose a delta that depends only on epsilon and not on x and y, such that this absolute value, x minus y times x plus y, is less than epsilon whenever the absolute value of x minus y is less than delta. So if we consider the expression the absolute value of x plus y right here, so we see we have the absolute value of x minus y and multiplying by the absolute value of x plus y. Basically, we can, if we make x and y arbitrarily large, then this will no longer depend on epsilon. And so you can make it even bigger than epsilon. So if, let's say, x and y are huge, then when you multiply it by the absolute value of x minus y, that's going to be greater than or equal to epsilon. So therefore, x squared is not uniformly continuous on R.